The far side of the moon is the closest unknown world we have. Not because we can't see it anymore, we've mapped it in insane detail, but because it's a place where the rules feel slightly different. It's the side of the moon Earth never shows us, the side that stayed hidden from every human eye in history, until the space age cracked the door open. And the moment we finally looked, we realized something unsettling. The moon isn't symmetrical. It isn't balanced. It isn't even quiet in the way we imagined. One side is familiar. Broad, dark plains, smoother basins, those iconic seas that make the moon look like a face at night. The other side is brutal, heavily cratered, scarred, ancient, like a battlefield that never healed. So the obvious question becomes, why? Why does the near side look like it was repainted, while the far side looks like it stayed frozen in time? Why is the crust thicker on one side and thinner on the other? Why do the largest impact features and the deepest mysteries hide where Earth can't see them? NASA didn't find aliens back there. This is not that kind of story. What they found is more interesting because it's real, it's geological, gravitational, and strategic. The far side is basically a vault, a locked room in the solar system, and the things we're learning from it are quietly rewriting what we thought we knew about the moon and what we're planning to do next. Because if humanity is going to build a future on the moon, the far side is not just a location, it's a prize, and maybe the most important frontier of the next space race. The reason the far side stayed hidden for so long is simple. The moon is tidally locked. It rotates at the same pace it orbits Earth, like a dancer that always keeps the same face toward its partner. That means the same half of the moon has watched Earth rise and set for billions of years, and the other half has never once seen our planet. For ancient humans, the far side was pure imagination, myths, guesswork. The moon was a symbol, romantic, divine, mysterious. But even when telescopes improved, even when we became masters of mapping planets, the far side remained unreachable. Until spacecraft. When probes finally photographed it, the first reaction wasn't wonder. It was confusion. The far side didn't look like the moon people knew. It looked older, rougher, more damaged. Where were the giant dark maria, those lava plains that cover the near side? Why wasn't the far side flooded with basalt in the same way? That one question, why the far side is missing those dark plains, became a long chain of discoveries. And the deeper we looked, the stranger it got. The leading idea is that the moon's crust is thicker on the far side and thinner on the near side. A thicker crust is like a stronger lid on a boiling pot. Even if the interior heats up, magma has a harder time reaching the surface. On the near side, the crust is thinner, so volcanic flooding happened more easily, and those huge lava plains formed. But here's where it gets weird. A crust isn't supposed to be lopsided like that. Not this dramatically. Not for a world that formed in a giant collision and then cooled down over time. That imbalance implies something happened early in the moon's history, something powerful enough to permanently shift the structure of an entire world. One hypothesis is that Earth itself changed the moon while it was still young. Imagine the early Earth glowing hotter than any furnace, radiating heat into space like a cosmic ember. The side of the moon facing Earth may have stayed warmer longer, keeping its crust thinner and easier to fracture. Meanwhile, the far side cooled faster and thickened into a tougher shell. Another possibility is that impacts did it. Massive impacts that punched deep into the moon's crust, weakening one side more than the other. And that brings us to the monster hiding on the far side. The South Pole Aitken Basin. This is one of the largest impact craters in the entire solar system. It's so enormous it doesn't even feel like a crater. It feels like a region. It stretches across a huge portion of the far side near the lunar South Pole, and it's unbelievably ancient, formed early when the solar system was still chaotic and violent. If the moon is a museum of impacts, the South Pole Aitken Basin is the main exhibit. And NASA cares about this place for a reason that goes beyond curiosity. Because an impact this large may have excavated deep lunar material, possibly exposing what's beneath the crust. In other words, this is one of the best places to study the moon's interior without drilling miles down. If you want clues about how the moon formed what it's made of, and how its internal layers are structured. This basin is a jackpot, and it's not just one basin. The far side is full of ancient scars that never got covered up by later lava floods. It's like the near side had its old history wiped clean and repainted, while the far side kept every mark, every bruise, every clue. So when people say NASA found something on the far side, what they really mean is this. NASA found the moon's original story written in the oldest language possible: craters, gravity, and rock. But the far side doesn't just teach us about the past, it tells us about the future, because the far side is the quietest place near Earth. Quiet not in temperature, not in terrain, but in radio noise. Earth is loud. We scream into space constantly. Radio stations, satellites, military signals, radar, Wi-Fi, everything. All of it becomes a kind of invisible fog around our planet. On the far side, the moon blocks that noise, which means if you want to listen to the universe, truly listen to the faint signals that get drowned out near Earth, the far side is the best natural radio shield we have. This is why the far side is considered ideal for radio astronomy, especially for studying the early universe. There are signals out there that are so weak, so ancient, that modern instruments struggle to isolate them. Some of the most ambitious plans for future telescopes involve placing arrays on the far side, where Earth's interference can't reach. That's not sci-fi. That's strategy. In the long run, whoever builds infrastructure on the far side doesn't just claim land. They claim the cleanest listening post near Earth, a place where humanity can build the most sensitive ears it has ever created. And that's where things start to feel competitive, because NASA isn't the only one looking at the far side anymore. China has already demonstrated it can land there. That matters because landing on the far side is a communication problem as much as a navigation problem. You can't talk directly to Earth from the far side. Your signals are blocked by the moon itself. To operate there, you need relay satellites positioned perfectly to bounce communications around the lunar body. That's a level of infrastructure, a sign of long-term intent. So now the far side becomes more than a scientific location. It becomes a strategic foothold. If you can reliably operate on the far side, you can build. If you can build, you can stay. If you can stay, you can control the most unique environment in the Earth-Moon system. And here's where the changes everything part becomes real. Because the far side isn't just different on the surface, it's different in mass distribution too. The moon has gravitational quirks, regions where gravity is slightly stronger or weaker because of hidden structures below. On the near side, many of these mass concentrations, often called mascons, are linked to lava-filled basins, dense material pooled in ancient impact sites, changing the gravitational field. On the far side, the story isn't as simple. The crust thickness, the impact history, the lack of Maria, it all creates a different gravitational personality. And that matters because gravity is destiny in space operations. It affects orbit stability, navigation, landings, long-term station keeping, and how easy or hard it is to build reliable routes around the moon. If you're planning permanent lunar infrastructure, bases, satellites, supply chains, gravity anomalies are not trivia. They're the hidden currents in the ocean, but perhaps the biggest reason the far side is becoming the focus of the future is this. The moon's South Pole region, overlapping with far side territory, is where many missions are targeting resources, particularly water ice in permanently shadowed craters. Water is everything. Drinkable water, oxygen for breathing, hydrogen for rocket fuel, and a foundation for industry. If you can extract ice and break it apart, you can produce propellant. And if you can produce propellant on the moon, you change the economics of space travel. Suddenly, the moon becomes a gas station, a refueling port, a staging ground, and the far side becomes a neighbor to the most valuable territory on the moon. This is why the moon's dark side is turning into the brightest strategic target of the next era, not because it hides monsters, but because it hides advantages. Now, let's talk about the psychological impact of all this, because it matters more than people admit. The far side is the closest place a human can go and still feel truly cut off from Earth. On the near side, Earth hangs in the sky like a constant reminder. Home is right there. Rescue might be possible. Communication is direct. The world is watching, On the far side, Earth disappears. You can't see it. You can't talk directly to it. You exist behind a wall. The moon literally blocks your connection to the planet that created you. That changes how space feels. It changes how isolation feels. It changes how permanent feels. If humans build on the far side, it will be the first time our species lives somewhere while the home world is not even visible. That's not just a milestone. That's a mental shift. And it raises a question that sounds philosophical, but is actually practical. What happens to a civilization when the sky no longer contains its birthplace? That's why the far side is more than geology. It's a psychological frontier, a cultural frontier. Now there's a misconception we should kill right here. The far side isn't dark. It gets sunlight like any other place on the moon. The term dark side is poetic, not physical. What's dark is our relationship to it, our history with it. It's the side that was hidden from every myth, every poet, every ancient civilization. The side that didn't participate in human imagination until machines showed it to us. And the moment machines showed it to us, the moon stopped being simple. It became a complicated world with a secret half. But here's the twist. The far side isn't only a place where we find differences. It's a place where we find clues about the entire inner solar system. Because the far side preserves impacts that the near side lost. Those impacts are timestamps. They tell us about periods when the solar system was more violent. They hint at the frequency of asteroid bombardment. They help calibrate the ages of surfaces across other worlds. When you study the far side, you're not just studying the moon, you're studying the solar system's childhood. And that has consequences for how we think about Earth too. Because if the moon was battered, Earth was battered. The moon just saved the evidence better. So when NASA and other agencies analyze far-side crater fields, they're reading a record of cosmic danger, how often it happened, how intense it was, and what it could mean for future risk. This is why the far side matters for planetary defense, for predicting long-term hazards, for understanding the environment our civilization is expanding into. And now we come to the part that feels like a switch flipping on. Because everything we've talked about, resources, radio silence, ancient basins, gravity anomalies, adds up to one conclusion. The far side is not a curiosity. It is the next arena. The space race used to be about firsts. First orbit, first landing, first footprints. The modern space race is about infrastructure, about supply chains, about who can create a permanent presence. And if you believe we're headed toward lunar bases, manufacturing, astronomy, and off-world fuel production, then the far side is not optional. It's inevitable. The only question is, who gets there first, and what do they build? A scientific outpost? A mining network? A radio telescope array that listens to the first whispers of the universe? Or a city, underground, protected, stable, built in lava tubes near the poles, drawing water from shadowed craters and powering itself through long nights? That last part might sound like a leap, but it isn't, because the logic is brutal and simple. On the moon's surface, you fight everything: radiation, temperature swings, dust, micrometeorites. Underground, the moon becomes survivable. On the far side, the moon becomes quiet. Near the poles, the moon becomes useful. Combine survivable, quiet, and useful. And you don't just get a base. You get the beginning of a new world. So what did NASA find on the far side that changes everything? They found the moon's other half is not a mirror. It's a vault, a place that preserved ancient history, offers unmatched radio silence, sits near the most valuable resources, and forces humanity to think beyond the comfort of always seeing Earth in the sky. The far side is where the moon stops being a symbol and starts being territory. And that is exactly why the next decade will be so important. Because the first nation to build real infrastructure, they won't just win a news cycle. They'll write the rules for what comes next. Science, economics, and human presence beyond Earth. The far side of the moon used to be hidden from humanity. Now it's calling us. And once we answer, space exploration stops being a visit. It becomes a migration.